Before we get any further, I'm gonna show you how to break these down in the fast-growing hierarchy. Let's have psi omega first. Let's just have a value of 3. But before we break this down, we first need to know the counting sequence of psi omega. The first element is psi 0. The second element is psi omega. But instead of a capital omega, we replace it with the previous element of the counting sequence, which is psi 0. Now the third element is a psi omega, except omega is replaced by the previous element. This series continues on like this. Now going back to the fast-growing hierarchy, we diagonalize it with the third element of the counting sequence. Psi 0, as we know, is equal to epsilon 0. And as we know, epsilon naught of 3 is omega cubed of 3. Now psi omega cubed is epsilon omega cubed. I'll just halt right here. Now let's have psi omega squared. Now let's determine the counting sequence of psi omega squared. The first element is psi 0. Now the second element is psi omega squared. Now let's do some simplification here. We know that omega squared is the same as omega times omega. Now this omega right here, you replace it with the previous element of the counting sequence. Now the third element, which is psi omega times omega, now omega is replaced by the previous element. Now let's translate these into ordinals. Psi 0 collapses to epsilon 0. Now what about psi omega times psi 0? Remember in our previous video, we said that psi omega times A is equal to zeta A minus 1. Because we have omega times psi 0, this collapses into zeta epsilon naught. Now psi omega times zeta epsilon naught, now this collapses with zeta with the subscript of zeta epsilon naught. In our previous video, we have known that psi omega squared is equal to eta naught. But notice that their index is epsilon naught. Psi omega squared resembles eta naught, but is not equal to eta naught. So we still have to use the respective element. Now let's have psi omega to the omega to the omega. As usual, the counting element starts with psi 0. The second element is psi omega to the omega to the omega, with the uppermost omega being replaced by the previous element. The third element is psi omega to the omega to the omega, with the uppermost omega being replaced by the previous element. Now let us zoom into this monstrosity. Psi 0, as we've known, we break it down to omega cubed. Now we do the rules of exponents. I'll just stop right here, as that gets really complicated. Now the counting sequence for the Beckman-Howard ordinal is psi omega to the omega, psi omega to the omega to the omega, and so on. The Beckman-Howard ordinal can also be written like this. Now no need to worry why it looks like this. This is just the same as an infinite exponentiation of capital omegas. This can also be written as psi 10. If we do psi 1a, this will be equal to epsilon omega plus 1 plus a. If we do psi 1 capital omega, this will be zeta omega plus 1. If we do psi 1 omega times a, this will be zeta omega plus 1 plus a. If we do psi 1 omega to the omega times a, this will be gamma omega plus 1 plus a. We can also exponentiate capital omegas infinitely. This will be psi 1 epsilon omega plus 1. This can also be written as psi 2 0. We can have psi 3. We can have psi 4. We can keep incrementing the subscript of psi. We can even do stuff like psi omega. Let's have psi omega of 3. Omega, as we know, turns into a 3. We break this down into psi 2 epsilon omega plus 1. This also turns into omega to the omega to the omega. Now this breaks down the same way we did a while ago, except now the psi's have a subscript of 2 instead of just a plain psi. We can even have stuff like psi gamma naught, or we can even have an infinite nesting of psi functions.